What's up, math fans? If I ever do a topic that you're not quite sure about, you can always look back in my playlist because they kind of go in order. It helps to know what came before. But I do my best to explain it so that even if you're seeing this isolated video, you can still get it. So this video is about finding an inverse functions. Now, I used to use the word inverse to mean the inverse operation, meaning the opposite operation. But here I'm doing inverse functions, which is a little different. An inverse function is kind of the opposite, but it's the opposite in terms of x and y. I'm switching x and y. So basically, if you can remember switch and solve, you'll know what to do. You switch the x with the y, and then you solve for y if it's an equation or a function. Here, really basic thing, there's not much work to do. If you take the point 2, 7, and I ask you what the inverse of 2, 7 is, excuse me, the inverse is you just switch the x and the y. So understand first that coordinates are in the form xy. So if I was going to find the inverse, that would be instead of 2, 7, it is now 7, 2, and that is the end of that. Inverse is switch, simple as that, all right? If you wanted a visual picture of that, I'm going to plot first 2, 7 on a graph. So 2, 7 is actually, let me get rid of this. 2, 7 is this point right here, okay? And the reason I drew this line is because it comes from here, y equals x. The line y equals x is a diagonal line that goes through the origin. You don't believe me? Think about all the points where y is the same as x. That would be 0, 0, right there. 1, 1, 2, 2, 3, 3, 4, 4, etc. Even negative, negative 5, etc. So it's a diagonal line straight through the origin. So what an inverse does is it takes a point and it reflects it over that line y equals x. So if you have a diagonal line and I'm up here, now I'm down there. It's kind of like I'm here, I look directly at the line. Where do I reach on the other side? Where's my reflection? Well, that would be 7, 2, which is about right there, okay? Notice in the diagram that's a perpendicular. You're looking directly at the line, not on any angles. Okay, so that's just a visual representation, but this video is going to be mostly algebraic. So I've given you an equation of a line, an annoying line because there's a fraction, but no big deal. And the rule is to find the inverse, you just switch and solve for y. All right, I didn't say that, but switch and solve for y. So let's see, how can I switch if there's no y there? Oh yeah, I learned something. F of x is just a fancy way, function notation of saying y. So that is really this. Now, since they're the same, I haven't done anything yet. Now I'm going to do the switch move. So I'm going to switch my x and my y. Wherever y was, x goes. Wherever x was, y goes. That's what an inverse is. You're switching. So, I guess it's x equals y plus 6 over 2. That's it. This is the inverse of that. But you also have to show your skills and solve for y. So how do I get y alone? I'm not really sure. Maybe I should multiply by 2 on both sides. What that does is it cancels out the 2's. And now I have 2x equals y plus 6. Y plus 6. How do I get y alone? The other kind of inverse that I say, which is the inverse operation. Subtract 6. 6 is gone, y is alone, and I'll write it up here. Y equals 2x minus 6. 2x minus 6. This is the inverse of this. So just to be careful, this is a different y than this. So rather than use y, to be careful, we use f inverse of x. Inverse is a little -1 in the corner. F inverse, if you can't see that, it's f inverse of x equals 2x minus 6. Okay? That just means the new y. You could have written y sub 1 maybe or something like that. Alright, so try it again, pause it, and then see if our answers match. So let's see here. This is the same thing. In the interest of space, I'm going to kill the f of x right away. Call it y. So y equals and y equals. Now, if I want the inverse, I'm going to switch. So instead of y equals that, I'm going to say x equals 4/5 y minus 7, and I have to solve for y. So you just need some simple algebra skills. First, I'm going to add 7 to both sides. And now 4/5 y equals, I'm just switching sides. I'm going to write this on this side here. What does it say? X plus 7? So then you write x plus 7. Remember, they're not like terms. Just write what you see. I want to get y alone, so in one shot you multiply by 5/4, but I'll do it step by step. So if I want to get rid of that fraction, the denominator of 5, I'm going to multiply by 5 in every single step. So now I have 4y equals 5x plus 35, and then to get y alone, I'm going to divide by the coefficient, which is 4. So now my f inverse of x is equal to that. And you don't really have to get fancy. You can write it just like that. So there is your answer to number 3. Now let me clear some space and get number 4 done in case you're curious. So again, I got to switch. So I'm going to say x equals 2y minus 1, and this is probably the easiest one. That's why I don't know why I left it for last. Let me get y alone here. So what do I have? X plus 1 equals 2y. Divide by the coefficient, and look at me, y equals x plus 1 over 2. Just write what you see and you're done. Of course, to be clear, you can write it as f inverse of x equals that, or you can be even super clear and write it as x over 2 plus 1/2. That way, in case you're asked to graph this, you would start at 1/2 and then you would go up 1 over 2 as your slope. You'd get a line here, you'd get a line here, and looks like I made a mistake, so I hope you caught that mistake. Good thing I paid attention. This is actually a plus 1 here, so I'm not sure why I wrote minus 1. So if that was a plus 1 originally, in order to cancel it out, I'm going to subtract 1 on both sides. So this is a minus sign. This is a minus sign. And this is a minus sign. All right? And of course, again, like I said, if you wanted to graph this, you'd have a line here, you'd have a line here. Easy to graph. All right? Thanks for watching. See ya.